Swayam Prabha. Digital India. Educated India.
Now I am not mapping any 3 variables to some 3 variables. I want to map dotted line segments onto dotted line segments. What is a dotted line segment? It is a geometrical object which will have multiple representation, that is multiple 3 numbers representing the same vector. Okay. So now then how do I construct such a linear function which will map, which is invariant to this multiple representations of a dotted line segment is a question. Okay. To answer that, we have to look into tensor algebra. Okay. Now what is tensor algebra is? A tensor, a second order tensor. Why this is called as a second order we will see shortly. A second order tensor is a linear mapping between two directed line segments, that is if x and y are directed line segments, then y equal to a times x, where a is a second order tensor. Okay. Now I want to generate representations for this linear function just like I generated representations for the vector. Okay. Now to do that we have to understand one more product involving two vectors, that is called as a tensor product. Between vectors A and B is defined as A tensor product B acted upon by C is defined as B dot with C times A, where C is any vector and A tensor product B is a second order tensor. Okay. This is a definition of a second order tensor. Okay. So this can be written as A times C equal to x, where A is A tensor product B and x in this case happens to be B dot C times A, that is A vector scaled by the position of B on C. Okay. This is a second order tensor which is a special second order tensor, because it is not a general second order tensor, it is an example of a second order tensor. A tensor product B is an example of a second order tensor. Okay. Now let me go ahead and define a general second order tensor. A is written as Aij, Ei tensor product Ej, where I have to sum I equal to 1 2 3 and I have to sum j equal to 1 2 3. What this means is this A11 E1 tensor product E1 plus A12 E1 tensor product E2 plus A13 E1 tensor product E3 plus A21 where this is E2 tensor product E1 plus A22 E2 tensor product E2 plus A23 E2 tensor product E3 plus A31 E3 tensor product E1 plus A32 E3 tensor product E2 plus A33 E3 tensor product E3. Okay, this is a linear combination of nine tensor products and here E1, E2, E3 are the orthonormal basis vectors. Okay, that is the coordinate basis that you choose to represent any other data line segments. Okay, by the way, a tensor product is called as dyad and a linear combination of tensor products or dyads is called as a dyadic. Okay. Now what I am interested is how to find the components Aij. Find the components Aij. Okay, we had written y vector as a times x, right. Okay, now what is the component of y I? Yi is y dotted with ei. So I will have from here this will imply a of x dotted with ei is yi. From here this implies a of x dotted with ei is this. Now what is x? X I can write it as a times x j e j dotted with ei. Okay, that is how I represent x. So that will be x j scalar. So I pull it out of the equation e j dotted with ei. Okay, now if I say this is a I j, then what I get is I get this vector y I equal to this matrix times A times this vector x, because this is nothing but a I j x j. I am summing up the column of the matrix with the column vector j. Okay, so this is a valid operation, matrix vector multiplication operation, and hence you have this representation for a times x. Okay. In what I have done here is I have represented these components of A. What I have done here is I have represented these components of A in terms of a 3 by 3 matrix with the corresponding first index denoting the row and second index denoting the column. Okay, that is what I have done here when I write it like this. Okay, now so we find that Aij would be, now we find that from this Aij is a times Ej dotted with Ei, right. That is how you find the components. So, I can write general second order tensor can be written as A times E j dotted with E I tensor product E j. Here I and j are dummy index because they are repeated twice on the same side of the equal to sign, which means I have to sum them from 1 to 3. Okay. Now, let us find the components of, let us find the components of the tensor A tensor product B. Okay, I would apply the same rule. So, A tensor product B, the ij component would be A tensor product B acted upon by Ej dotted with Ei. So, this is nothing but from the definition of the tensor product A B dotted with Ej dotted with Ei. This is nothing but A dotted with Ei times B dotted with Ej. Okay. This is nothing but Ai Bj. So, the matrix components of A tensor product B can be written as A1 B1, A1 B2, A1 B3, A2 B1, A2 B2, A2 B3, A3 B1, A3 B2, A3 B3. This is nothing but A1, A2, A3 multiplied by B1, B2, B3. That is, if this is a 3 by 1 vector, this is a 1 by 3 vector. So, the product is a 3 by 3 matrix. In other words, this is A vector times B transpose. If I view if vectors are column vector. Okay, if I view the vector means I arrange the components of a vector as a column, then it is called as a column vector. So, then it will be A B transpose. Okay. In contrast, a scalar product between two vectors A dotted with B would be A transpose B. Here A transpose will be 1 by 3, this is 3 by 1, hence it is a 1 by 1 scalar value. Okay. So, that is what a tensor product means. Tensor product means of two vectors is A times B transpose. Okay. Let us move a little bit further and understand what this basis vector tensor basis mean. Okay. Now, I am interested in finding E1 tensor product E1. This will be 1 0 0 1 0 0. So, this is nothing but 1 0 0 0 0 0 0 0 0. Similarly, E1 tensor product E2 would be 1 0 0 0 1 0, which will be 0 1 0 0 0 0 0 0 0. In general, Ei tensor product Ej means only the ijth component is 1 and the rest are zeros. Rest of the components are zeros. Okay. So, what does that mean? It means just like for a vector you have 1 0 0 0 1 0 0 0 1 as the basis vectors. For the tensor representation, one of the matrix entries around being 1 and rest of them being 0 are the basis vectors for representing the tensor. Okay. So, this forms EI tensor about EJ forms the basis for second order tensor. Okay. EI tensor about EJ forms the basis for the second order tensor. Okay. Now, finally, let us look at whether any matrix is a second order tensor. Answer is emphatically no, because it does not transform the way a tensor should transform. Any matrix need not, it is just a 3 by 3 entry of numbers. When the coordinate system changes, there is no meaning as to how the components of the matrix will change. For example, transformation matrix Q is a matrix and it is not a second order tensor. Okay. So, any matrix will not be a second order tensor, but second order tensors can be represented as a matrix. Okay, one of the representation of second order tensors is a matrix. Another representation is, I can write the components of A as a 9 by 1 vector also, A11, A22, A33, A12, like this. I can continue as a 9 by 1 vector also, the components. These are mere representations of a second order tensor for convenience of calculations. What is its true meaning? Just like a data line segment has a direction and a magnitude fixed irrespective of how you represent it, there is a fixed representations for a second order tensor, that is a set of matrices will form together a second order tensor. In the next class what we will do is we will find the components of a stress tensor, and then we will go to forward to look at how a stress tensor will transform to changes in coordinate basis. There we will study Morse circle, wherein all the points on the circle will represent the same stress state or the same tensor which represents the stress. Okay. So, with this we will conclude this lecture. What we have seen is, we have seen that the traction in general depends upon the time position vector in the space and the normal, or it depends upon the time the particle that you are looking at and the normal to the cut surface that passes through that particle. Okay. And then we went ahead and looked what a linear function is, and then we went ahead and looked what a tensor algebra is, how to represent a linear function of two data line segments. Okay. Thank you.